Okay, you're asked to find the derivative of this function right here. It's rewritten right here as big F of x. We want to find the derivative of this term, the derivative of this term, and substitute. So here's the work for that first term. And by the way, let's make the observation that for this function, x has to be between 8 and -8, both because of the square root and because of the inverse sign. So for this first term, we'll use the product rule. I won't go through it all, but we did say the first function times the derivative of the second. Power rule followed by the chain rule, plus the second function times the derivative of the first, which is just a 1. That's what the first term simplifies to, -x² over the square root. And then if you want to combine those two fractions into one, you could leave it like this for the time being. Okay, and over here, we want to find the derivative of 64 inverse sine of x over 8. We know that the derivative inverse sine is 1 over square root of 1 minus u squared. So this is u squared right here, x over 8 quantity squared. And that simplifies to this. And so if I do that substitution of those derivative of those two terms multiplied by 1/2, these two terms have a common denominator, so I can add the numerators. And then if you divide both sides of the numerator by 2, this is what you get. A couple ways to get from here to here. Rationalize the denominator, or picture this with an exponent of 1 and this with an exponent of 1/2. So 1 minus 1/2 gives you an extra 1/2 in the numerator. So there's f prime. And noting that this radical appears in the denominator for the derivative, we remove the or equal to symbols. This is the graph of the derivative right here, top half of a semicircle. And at x equals 8, the tangent lines are vertical, and at -8. An interesting idea is if we take that derivative and say, what's the antiderivative? Do you get what you started with? And here is the setup for trigonometric substitution. We want to use the sine ratio because of this something perfect square minus x squared. So the sine of theta is x over 8, which means theta is the inverse sine of x over 8. We're going to let theta be between -pi over 2 and pi over 2 inclusive. And that means down here, the cosine of theta is positive, so we can drop the absolute value symbol because we're in the first or fourth quadrant. And so here's the trig substitution. And we have to find the antiderivative of cosine squared, which is a pretty standard thing using power reduction formula. There's a formula for cosine squared. So we're finding the antiderivative of 1/2 of cosine 2 theta plus the antiderivative of 1/2. And that's what you get. And from the right triangle for sine of theta, we can substitute x over 8 for the cosine of theta. Square root of 64 minus x squared over 8. So there's the antiderivative of cosine squared in terms of x. We got to replace that up here. In other words, multiply by the 64 still. And there we go. We get the same thing we started with on the previous board. Okay, there you go. Hope that helped. If you have any questions, post a comment.